See, hello, welcome. So, trying to do a few things here, setting up wise. What I wanted to do with this stream, there we go, is basically a chat and math. I know, I know, of all the subjects possible. I think there's not enough of these um, sort of educational streams. There's plenty of others. Uh, some might say, why not just make a stream eating food? But we're going to make this entertaining, educational, most importantly, and interactive. So I'm horrible normally at keeping track of chat, but I'm going to go ahead and make that a priority and set up a couple of things. Let me see. My cat's going crazy. Absolutely bonkers. He'll probably come in and make his debut as well once he settles down. So let me see this testing chat. Let me see if I got the right one. Okay. What was that? Oh, battery. What I'm gonna do in this stream is basically if nothing's happening, I'm just gonna go over some common issues that a lot of my students are having. A lot of grades, all grades, really. Um, I'd say starting from about fourth grade up to 12th grade. And we're gonna go over common issues when we get started. Let me just set up, make sure the stream's working, make sure I got eyes on the chat. Now, I normally do gaming, I normally do programming, and this was kind of like the next step, uh, streaming mathematics, which is probably going to be the most difficult one, due to obvious reasons of math and its lack of entertainment in most cases. Cool. Okay, chat's good. Chat's good. Stream's good. So, yeah, welcome. Uh, we will try and make math entertaining. I even wanted to put some music in the background, and I know about the whole copyright stuff, so I made some AI music. I might drop some on the back at some point. But I also want to do this because like this is kind of my more productive feature, personally, is going through a stream, going through the things, then taking my stream, downloading it, and editing it. Also, check out that little blob. How fun is that? And then when I edit it, I'll be able to kind of compact all the stuff we go through in stream, in chat, in all the places. And keep in mind, um, feel free to, I'm going to actually add another thing here. Feel free to leave comments if after the stream you make it and you can't enter chat. So leave anything you want to go over for next stream. And yeah, we'll go over it. I'll make sure to note it for the future. So no one gets left behind. You can make it on time, as typical classroom attendance. Or you can just basically watch this after it's already been done streaming. and leave your comments on what you might want to see futuristically and other similar streams. Now, I decided I was actually playing around with it, got some AI help. I really like the WTF. Not your typical WTF, obviously. What the formula? Because that is, in essence, the root of the question most students have. What the formula? Maybe not in the exact word of F, but close enough to kind of be humorous, if anything. Okay, let's see, stream good. I'm gonna do a little thing here, a little bit on my network online where you can find me. So yeah, right here, you'll see a little marquee. All of this is HTML, even the little hexagonal patterns you'll see in the background. So I do a lot of teaching, from mathematics to programming, and you can find more on any of these locations here as it's scrolling by. Try not to make it too much, too saturated, too much stuff happening, but I think this should be just enough to keep the attention. All right. So let's go over some math until anyone decides to chime in with any of their personal uh, questions. So I've got a couple of students that essentially, oh gosh, hold on. This tablet likes to go ham when it's plugged in for some reason. So this is essentially from a student. Now, you may be here to learn math. That's fine. And you may even be here to learn how to teach math. That's also great. This is not for any one specific type of individual. Rather, I will go over my experiences of, I think, 13 plus years now, um, and definitely over 5,000 students. I lost count, so I'm going to just call it 5,000 plus. And the experiences I've had with how to present certain things, how to answer certain questions. Now, I won't have the exact questions that the student has because normally I do live one-to-one remote tutoring and recording and replaying some of it. I might be able to basically create some videos in the future, but I'm also looking at keeping it very uh, identity neutral based on the students that are actually learning with me. So I got to do a lot of editing. That's not my fun part. I don't like editing. Um, Futuristically, maybe I'll get better at it, more effective. So that's also why I like to stream, particularly. But again, student, teacher, tutor, instructor, and even sometimes professors. They may come through one of these streams and want to understand potentially how they can present information better, clearer, or in some form help themselves improve on their methods. So here we see one of my students learning just the basics of math, and it's entering the algebra space. And it's really the variables that come to mind. The variables, right? So let's consider a couple of pieces here. We'll start without variables, just your typical math processes. But everyone always starts to get a little, I guess, confused, overstimulated when letters start coming into play. Because, all right, we're learning how to make words and sentences and speak to each other. But now all of a sudden, the things I know about words and letters completely adjust themselves. So it's not crazy different. In fact, I'm going to start with your typical format, PEMDAS. This is the guiding factor to solving both straightforward, just numerical operations, adding, subtracting, multiplying, dividing. And there's a trick with this same factor, this same set of words or letters and acronyms that we can actually use to solve for variables. I'm going to be looking over here a lot because that's where my stream is, so just making sure everything's clear. Camera's right there. Cameras, man. I don't like looking at cameras too much. So, in a typical sense, you have a problem with an equal sign. Now, in this case, we don't need an equal sign because it's not showing us anything at the end. We are solving piece by piece. We would actually call this an expression. Anything without an equal is a solvable expression, especially if it's only numerical values. And when we add the equals, we start going into what we call an equation. There's a couple of things I just immediately want to go over, but to end my tangent distractions, I'm just going to go straight for the final here. When we're looking at PEMDAS with numbers, just straight up numerical values, we approach it using the left hand to right hand side process. We try to identify pieces we want to combine. P for parentheses, E for exponents, M for multiplication, D for division, addition and subtraction. This is the order in which we're seeking to find within the whole expression. You can move around. A lot of students will kind of try and do the left hand to right hand and then approach this in the same way that we would read a book. So they immediately start from the left, go to the right. But we're not limited to this. In fact, if we look at PEMDAS, we've already got the first piece to our puzzle here. If I see parentheses with multiple numbers inside, an operation between numbers. Remember, operations are addition, subtraction, multiplication, division. I'll immediately find this guy. He's at the end. That's fine. We don't have to necessarily go from the left to the right. In fact, it's best if you find it this format because it'll be easier to essentially start simplifying the math, making it easier for us to see the next steps. So rewriting is going to be a consistency here. You can't consider, oh, I'm just going to do it all in one line, especially as problems get a bit more complicated. So from this point, I can automatically subtract 3 minus 2, giving me a 1. Putting our parentheses still around the 1 just to keep that as in mind. And then not touching anything else, at least for the beginning, because a lot of students want to do multiple pieces at once. If you're fluid with this and you're comfortable with this, then it's very straightforward to just start doing 5 times 4 and all the others. But I like to always recommend take your time in the beginning and rewrite the things that we haven't touched yet. So we combined 3 minus 2. That's all we've done so far. Let me see. Why are you? Okay. So we've combined 3 minus 2, and now we've simplified it. Now we don't have this extra 2 values in the parentheses. And that's the goal, is to make it simple for you, not to try and rush things. And when you do take the time to rewrite, you reduce the errors you'll make in your actual mathematics. Now, from here, we can technically go to the next step. After parentheses, we will check for exponents. Well, we don't have any of those, so we skip that. Multiplication. Well, we have two of those, here and here. So in this case, yeah, you can do these separately because they're separated by a plus in between, what we would call terms. One thing I do want to diverge on real quick, still dealing with PEMDAS, is the relationship between certain values. Addition and subtraction have a what I call sibling relationship, brother and sister, opposites in some form, but there's always a case for that close tie between the two. Multiplication and division also have their own relationship as far as siblinghood. They also reach across and relate to each other, multiplication with addition, division with subtraction, and more of like a cousin relationship where they're somewhat similar, but they do have components, small pieces uh, of each other, especially as we think about multiplication and division. Just as a simple factor, if I do 2 plus 2 plus 2 plus 2, the relationship between this and multiplication, so addition, is simply changing this to 2 times 4. So there's your sort of sibling relationship. It's the same answer in the end. I'm also trying to keep track of chat just in case someone pops up. But in the case that they have this relationship, they're going to give us the same answer. You add 2 4 times, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. And if you multiply 2 times 4, you still get 8. So this is what I mean with the relationship between addition and multiplication, at least. As far as addition and subtraction, I like to think of them as spaces. One case I like to say is that this is more like an Elmer's glue. When you put together um, a piece of paper and you want to make a collage, you probably put Elmer's glue, that white bottle with the, I think it was like a bull or a cow or something in the front. I can't remember. It's not the strongest of glues, so it lets us basically, it doesn't interrupt us. It's not hard to remove, right? However, I like to think as multiplication and division is more of a super glue. I think I'm going to add more pens. Need more custom pens. So our multiplication and division is going to be like super glue. Elmer glue, super glue. Now, the practical meaning to this is that here we can multiply the 5 and the 4 and the 8 times 1 separately without taking into account the addition just yet. What I'll do from here is essentially just straight up multiply, and whatever has not been touched, I just rewrite. So 20 for 5 times 4, 8 for 8 times 1, and the plus gets rewritten as nothing has happened yet. This brings up certain memes we'll see online, so maybe I should pick up one of those memes for the lulz. Math order operation meme. And let's kind of do that. Because I do see a lot of answers that are viral math problem. All right. Let me see if I can just copy the image over. Yeah, whoa, large. Very large. So this brings up what you might see in social media. Some problem that everyone's got a unique answer for. Right. So how do we solve this knowing what we know now in PEMDAS? We haven't even entered variables and letters yet, so keep that in mind. What I've shown before is essentially the steps we'll take here. The first case is to look at for anything that's a parenthesis. There you go. And the reason most students will get this wrong is because, again, I mentioned that we like to think like we read from left to right, just like a book is read from left to right. But not necessarily the case that we have to approach. In fact, if we have parentheses, we better be doing that first before we go any further. So we'll take 6 divided by 2, add the 1 and 2 for 3, and then you'll notice which one changed and what stayed the same. So be in a habit to essentially rewrite stuff for your sake, for clarity. Now, the question is, all right, technically, the parentheses is just another way for us to say times. So I'm just going to rewrite the parentheses as a multiplication. Here is when the question arises. What do we do from here? In fact, it does really arise, and this might go in two different ways. In the pairing that we had, we still approach left to right, but it's a little bit more extreme here. If we have only multiplication and division, that's when we can do left to right. So in this case, we're going to approach the division first. Because there's two ways to really solve this. It's going to give us two totally different problems too. And I actually want to make sure that I'm not going to fall into this trap. You know, dun dun. Right. So that's the process. So this is where, okay, we drop to the right side. We did our parentheses because of the PEMDAS order. We can check mark that. Don't have exponents. And now we have multiplication division. Now, when I meant that we go from left to right, I'm not saying we're going multiplication first, division first. If we have nothing else around and we're really just dealing with multiplication and division, we're going to take the left-right reading approach. In the problem itself, the order matters here. So I'm not going to do the multiplication first because PEMDA says so. And this is where the tools we try to use sometimes can confuse us more than help. Because in PEMDAS, M is first, D is second. And we always teach go from left to right based on PEMDAS. That's why I kind of like to group multiplication and division and addition and subtraction. It's the same rule in addition and subtraction. If we only have things that add or things that subtract, then we just approach it from left to right as the whole problem order, not addition first, subtraction later. So because we only have multiplication and division, we're straightforward going to go from left to right and do 6 divided by 2 first. That's 3. And then we rewrite our other 3. And the correct answer is none. The confusing part here is I don't want to really go into the detail, but this is correct. So let's give it a green check mark. The incorrect red X is going to be if we did the 2 times 3 first, because that would be the confusion between following PEMDAS completely in the order in which multiplication and division pop up. If you multiply 2 times 3 first, then your actual answer and incorrect answer would be 1, 6 divided by 6. So when we say left to right, the first kind of order is to consider parentheses exponents. They're also, in a way, in a group. Consider them in pairs, a sibling pair, if you will. We do parentheses exponents first, multiplication, division second, addition, subtraction third. Notice we have 6 letters, but we're doing it in 3 steps. That's because I'm not singularly isolating multiplication and division. They are not separate. They are within the same square. So this is why this viral problem's pretty crazy. Yeah, the first step is to grab that parenthesis, just to kind of the basics of our order of operation. So this is what that is. PEMDAS is just a way for us to consider order of operations. Operations, of course, being addition, subtraction, division, multiplication, operations between numbers. And this tricky problem tends to kind of flow all over the place because first it does do a direct left to right with parentheses. So we focused on the 1 plus 2. Combining that, we had the parenthesis of 3. But because the parenthesis doesn't necessarily have anything else anymore, always remember another very often forgotten thing is that when you have parenthesis, you're actually multiplying the neighbors, which is a dot, which is another thing we'll kind of work with. We got a lot of symbols that pop up, and there's a reason for that too. So once you multiply 2 times 3, you're entering the wrong direction. This guy. Because maybe now our order made it explicitly associated with multiplication and division being separate, when they're technically, again, siblings. So as soon as we have a problem full of just a single type of these groupings, we approach it from the general left to right process. So we first found that 6 divided by 2 is 3, and then we brought down the other 3, and we multiplied that for the final correct answer. Cool. Still haven't gotten to variables yet. Now, some students will struggle with just the arithmetic, just the operations, adding, subtracting, um, let's say taking 14, subtracting from 7. Some have it memorized. Maybe we go a little bit further, subtracting from 9. Some may not have it memorized. And it's not a case for memorizing as much as it is having a couple of mental processes. And practice is really where this is going to help out. I've seen some students start at 9, go to 10, go to 11, go to 12, go to 13, go to 14. And then the answer is the numbers that we counted up to get to 14. So that's 5 numbers. So the answer is 5. That's one way to basically think about math. But with big numbers, it takes a while, and you have only 10 fingers on your hands. So if it goes beyond a certain number, it gets a bit extra. So what I like to do is think of it in 2 ways. I technically do say start from 9 to 10, that's a 1. But then from 10 to 14 is very easy, isn't it? Because from 10 to 14, it's just 4 values. You add the difference between 9 to 10, which is 1. Always go to the next 10, basically. Whatever your 10 is, go to that 10 and then complete that. And then when you go from 10 to 14 or 10 to 17 or whatever, you just remove the front number. And there's the same answer, 5. These are what we would call mental training exercises. There's a lot of tricks that we can adjust the way we think about when we do mathematics. Um, but it all depends on the individual. I've seen a lot of students find trouble with certain methods, but find comfort in other methods. It's because we all think differently. I've generally found this to be a little bit more comfortable. For instance, that one is not going to be one of the ones you can take a look at right away, right? So what I would do is say, hey, from 18 to 20, that's 2. And then from 20 to 37 is actually easier because that's 1 in the front and a 7. So that's 17. The answer is 19. So by those increments of 10, my favorite numbers are 5 and 10. Very straightforward. By those increments, we can find the subtraction between very large numbers, or if not that large. This one, gonna take a little extra, but still, 57, I'd still approach it the same way to 60 is 3. Then I'd go to 100, which is 40, and then I'd go to 183, which is 83. Boom. The math here is going to be a little bit difficult as well because addition beyond certain values. If I was to add 40 and 83, well, 4 and 8 is 12. 40 and 80 is 120. Put a 0 there. And then 40 plus 83 is 123. And you can just simplify down to the difference. Oh, no bueno, of 126. This requires practice with all kinds of sizes of numbers. And I like to always go into like an app store on my iPhone or on my Android and just practice, uh, just brute force the numbers into your head. Get comfortable with the process, and the faster you'll get, because in the end, your brain's a muscle. And this is what I tell all my students, your brain's a muscle. You use that calculator, it's just like going to the gym and having some sort of Optimus robot lift weights for you. You're not going to benefit in any way. The robot doesn't benefit either because it's programmed to do that and it's lifting all the weights for you while you're just watching. But the brain is indeed a muscle, and training your brain with vigorous exercises can help make it think much faster. It's never the case that anyone is dumb. No one is dumb. We just don't have enough practice. That's all it is. All right, so these are just the PEMDAS of numbers. We haven't scratched the surface of variable addition or including variables into our processes. That's really where equations start to happen. Right now, all of these can be expressed as an expression, an expression, an expression, and finally, the actual only legit equation here. Because we don't know what 9 is until we get all the numbers on the left side of the equal sign. This equal sign becomes the balance point. I always like to think of the equal sign, and probably every single class describes the equal sign as a balance. If we say 5 equals to 5, it literally means we have 5 objects in one, therefore we have to have 5 objects in the other, so that the scale is equal. This becomes a much more intricate piece of solving equations for the next step, where we enter algebra. Right now, we're still in the basic mathematics of things. PEMDAS, order of operation. We're thinking of the basic arithmetic and operations of numbers. The next step is to understand the equal sign and always think of it as a middle. That's the important part. If we see the equal sign as the middle of an equation and we have a left and a right, always two sides. And then the steps we have to take next won't be so difficult to find. Now, we do have cases where maybe we have an extra marble, making this a 6, breaking our balance, and then we have an issue. Most math will not, or most classes will not show you this very often because we always work with numbers that work. We always make sure the scales are balanced. When you get to algebra 2 and higher level classes, especially college, these become more useful to us to understand whether there is an answer or there is not an answer. But for everything in the 5th to 12th grade, we're not going to see an equal sign not be equal. We should keep in mind that it's possible and there's a certain meaning to it. But for our case, we don't need to worry about it. So when we deal with this, we can do a couple of pieces to kind of understand how math can change but still be the same. Maybe instead of 5, I have 2 plus 3. What would that mean? I just basically split them into two groups of marbles. It's still a total of 5. Therefore, it's still equal to 5. So even though numbers may look different, equations can eventually come together, get all the numbers, all the marbles in one big bunch, and you have your balanced equation. Now, where does variables fit in? This is where the tricky part can happen, but maybe if you see it this way, it won't be so tricky. A problem that has variables will have an unknown. In the early, before algebra stages of math, we normally show those variables as an empty box, like that. With that empty box, that's us saying, hey, you're about to find out that we're going to drop in some letters. But before we confuse you too much, think of the space, this little extra space. And then you would say, what makes 5 if we have a 3 plus something, an empty space that we can plug in a number into? Obviously, we know the answer because we just came from the answer on the balance scale. The whole concept, again, is to make sure we see where our balance is around the equal sign and then start plugging in values to maybe figure it out. That's the first step, is plugging into test. But when we enter variables, they start to adjust and we have better ways than just guessing what number might fit the equation. It's like trying to put one marble, seeing if the balance is equal. Then putting another marble, seeing if the balance is equal. In this case, 2 marbles would work. And the scale is pretty straightforward and not a lot of marbles to deal with. But when we get to more complicated problems, this method of guessing can take a long time. So there are, with PEMDAS, strategies we can do. But before we get to PEMDAS, let's focus in on this empty box. We should use a variable. We're ready for that. But I don't want to just yet because that box is still comforting. So instead of thinking of it as an empty box, let's think of it as a cardboard box. A little 3D cardboard box at your service. A little bit janky and sideways, but hey. And inside is where the number would be placed to balance this equation. So inside would normally be a number. So where do the variables come in? Well, it's just a label. You get a piece of paper, put some glue on it, boom, the label is X. So this box is labeled X. So that space that was empty at one point is now just a label. It's just X. And when we think about that, X is a place for a number that we have to essentially solve for. The cleaner way of writing all this without being creative is just putting a big variable X in its place. Straightforward. Think of X as the box without drawing the box. That's really it there. So that would mean we're still solving the same problem as before with the empty space, just having an X next to it or in its place instead of emptiness. And the whole purpose of a variable is to be replaced with a number to fit the equal sign, going way back to our balance. The answer will be 2. So we would say X is equal to 2. That would be a guess in my book or anyone that's a teacher because there's no work to show why it's 2. We just kind of put some marbles in and tested it out and oh look, 2 marbles plus 3 marbles is 5. Cool. Again, with different numbers, it may be a lot more difficult. So the actual strategy is now going to happen. Let me just kind of move some stuff around because I keep looking to the side, but I should probably move this here so it's a little bit straightforward. So even though we can kind of use that as all right, I know it's going to be 2, so when I do the math, then I have to make sure that it becomes 2. Whatever strategy I take, I have to end up with a 2. Because at the least, my guess I know is true. But I have to show the teacher my work, so let's just make sure we show the work. Here's where the work comes in. PEMDAS. Now, if we have only numbers, we start from the left and we go to the right. This is what we did in the first segment of this stream. This is where we can actually guide ourselves with variables as well. If we have X, Y, Z, whatever, P, just variables. We actually start from the right and go to the left. And we're not putting numbers together. This would be combining. That's what we would normally do with numbers, 2 plus 5, 2 plus 3, combine it into 1 with the sign in between, which is plus. So we get 5. What we do though is we move. You want to move the numbers around. And this is where that equal sign starts to pop in. I should probably say move around equals. This is where we have to start really noticing where the equal sign is. Here and here. The middle, the balance of our scale. And what I like to always start with is imagine your X. You are this box. Get creative. You are a variable. And sometimes we like to be alone by ourselves, just like our guest down here was. So our goal is to make this look like this. Again, the equal sign, the left side and the right side, the left side and the right side. Every time. It's basically to get that variable by itself or the x equals to something, or the y equals to something, or the p. It doesn't even matter which letter you use. Those are just labels on a box that changes from problem to problem. So don't hold tight on the variable itself as the letter being important, more like the position of where that variable is. That's what's important. Just like we concluded with the box, the empty box, it's next to a plus 3. So what number fits inside to make the equation work is the 2 plus 5. The missing piece is the 2. So it's not really what we put a label on or what kind of label we put, because we can put a y if we wanted to, we can put a z if we wanted to. The only thing that's going to change is that when we answer the question, one is going to be x equals 2, the other one is going to be y equals 2, or z equals. But the answer is still 2. That's why the letter is not important. It's the answer, it's the other piece. It's what is that location that's important. So again, staying away from looking at letters, variables, as something set in stone. They're not. They change from problem to problem, but the way we use them, this PEMDAS method that we're about to go through, is what's important. So whether you're X, Y, or Z, you're going to put yourself in that place, and you're going to look around and say, hey, what's around me that I want to move? Because I'm going to be introvert today. I don't want anything around me. So the answer there would be this 3. Because the 5, well, that's too far. It's already on the other side. It's probably in the other room. It's not bothering me. I'm having my self time. It's the 3 that's kind of like the little brother. All right, let me have some me time now. Go play outside. So that 3 being on the same side as X, who is me, who is the person that we're placing ourselves in, is the piece that's too close for comfort. So then our focus is, all right, I want to move this 3 to the other side. Remember that for PEMDAS, that's the key, is moving around the equal. So the question is, how do we move it? Well, the way we try to do this and figure it out, and can also be done in scale form. Let's imagine we're looking down at the scale. We've got 2 dishes. We know we have 5 marbles here. We have a box covering something, and we have 3 marbles here. These are our scales. So our goal is to figure out what's in the box. Well, how do we do that? What we do to one side, we can do to the other side, and as a puzzle, we can take stuff off to see when the balance stays the same. So maybe I'll take 3 from the left side and 3, wish I had a real scale to show you, from the other side. So what that really did is we just subtracted 3 marbles and subtracted 3 marbles from both sides of the equal, right? The little scale right there. And because of math, because the way that we approach this, the numbers are going to be the real case here. If I had an actual scale, then you'll see that these 2 are still balanced. Because once we removed these 3 from each side, what that means is that the 2 left over is equal to the missing covered up marbles that we cannot see. And if we take the box off, there should be 2 inside. So that's the method we take when we're dealing with an equal sign and how to move or do stuff around the equal sign. We have to do it to both sides each time in order to make sure the balance is there, because that's really the key is to keep the balance. And in the form of a scale, if we take one from the left, we take another from the right, or one from the left, one from the right. We take another from the left, we take one more from the right. So that's two from each side. And then maybe we'll do it again, a third and a third from each side. So taking out those three marbles from both sides, we'll notice that the scales are still equal. And even though we don't know what's under the box, now we can say, hey, maybe we test it out on the real life case, right? Maybe in real life, I take an extra four marble, even though there's nothing here I can take. It's empty except the box. But maybe in real life, I'll take an extra marble out, and all of a sudden, boom, the scale is different. As soon as that happens, I'm like, okay, I'll put in that marble back, and boom, we have our answer. The answer will be that exact piece. The amount that we have on the right plate is going to equal to the amount that's hidden in the left plate. And this is the balance of equations. So, how do we represent that in a straightforward math without any extra drawings? Well, it's based on PEMDAS. There's again that relationship in the sibling rivalhood of addition, subtraction, multiplication, and division. Now, I want to designate movement with addition and subtraction. Multiplication and division is more of a separation, to separate pieces from each other. We'll get to that later, but for now, we're just focusing on moving around the equal sign. So for me to get that x by itself, subtract 3, take 3 marbles off from the left side of our balanced equation, and then you take 3 from the right side to keep it balanced. And then we basically drop back to some regular PEMDAS combining numbers. So we'll do something like, all right, 3 minus 3, 0. 5 minus 3, 2. Then we can say, let's drop the x down. Nothing happened to the x, and the problem still is the same. That box, the little box that we don't know what's inside, it's still on the left plate. The equal sign still in the middle, just has a little thing there. Maybe I should modify this. There we go. Like that. And because 0 is a number that can exist or doesn't have to exist in the way that it's nothing, we don't have to write it down. So we can just remove the 0 and get our 2 in place. And there's our final mathematical process. Not a guess that we did in the beginning. This was the guess based on the missing piece. There was no math involved. We just said, hey, if I put 2 and 3 together, I get 5. So it must be that x is equal to 2. That's a guess. It'd be more like I guess that equal to 2, right? But mathematically, we've done the process to prove that x is equal to 2. And that's what's going to be important in any of the problems that you do. This is probably around 5th grade, 4th grade, 5th. 4th, I would say, but without the variables. 5th and 6th, you start entering variables. So this starts to happen around those, depending on state, country. I know Europe does stuff a lot faster. So you probably see these in 3rd or 4th grade. I'd say probably a year or two faster than the United States. It's surprising. Students in calculus start at 12th grade, most in Europe. Most United States states, start in college. You don't have to do calculus until you get to college, which, if you're here for the basics at this point, I'm talking Chinese now. So if you've stuck with me through this stuff, calculus is way beyond this level just yet. But I would work my way up to that given the time and the streams and the questions and the etc., etc. Now, why go over the basics if you already know them? Because what we assume we understand sometimes has missing pieces. So it's good to get a full bird's eye view and make sure that every little detail is understood. Like, yeah, maybe you'll understand to subtract 3 from both sides. But if I flip the sign, some may say, oh, wait, what do I do? Right? So, all based on a cumulative process, everything that we like, think about watching a movie. They say that when you watch a movie once, the first time, you'll probably remember 15 to 30% of the stuff in that movie. And I used to remember that too. I would literally go back in movies and be like, wait, I don't remember that. Wait, I don't remember that. Wait, when did that happen? And I would literally see about 15 or 30% of what I actually watched, I remembered. Nowadays, probably more. I think over time I've noticed it. So I've continuously trained my brain to do better. And this was around my high school years. So around high school, your brain is configured to only kind of remember the most explosive, interesting things. So when you rewatch some movies, you'll find new informations that make the movie even clearer or deeper in a storyline that you didn't think before. Same thing with anything we learn. We may get 30%, maybe 50 of mathematics in the past, but that other 50 can be a kind of blur in the background. Maybe it's there, but it was like, wait, how did I do that? It was something like this, but I don't remember exactly. So that's why it's always good to refresh, then have a second or third run through the movie so you remember and maybe even find something new you didn't remember before or you didn't notice before. I watch my movies maybe 2 or 3 times. I always find myself finding something interesting, kind of like detective work. What did I miss last time? Who's this? Who's that? Wait, where did that guy come in from? Detective work. So, just the way the brain works. Doing something once and finishing it with a test because you studied maybe the night before and you got a good grade on the test, 90, 95, doesn't mean that that one night of studying is going to stay with you for 3 or 4 or 5 or 10 years. In fact, I recommend not doing a one night study session because that's how you train your brain to prefer short term memory over long term memory. When you try to study for the last minute on the test, that just says, oh, I have something I have to do right now for tomorrow. And then once it's done, it goes away. If you study for the test with the content, the details, the chapters, the practice problems, as you go through your sessions, week by week by week, you just make sure everything is understood the first week, the second week, the third week, the fourth week. That's the long term brain coming in. And whatever you're learning in those long periods of time is actually going to be more permanent than you trying to study 4 weeks in one night before the test. Because your brain is how you train it. And if you train it just to learn that one night for that one day, that's called temporary memory. It's going to go away very quickly. And that's, I think, the biggest issue we have with a lot of methods of learning. We don't specify these details because it's the way the brain works. If you're in the woods with a bear, well, not even a bear, maybe a bear track. Maybe you see on the ground a big, big bear paw. Not like the paw, like, the dirt, not a dislocated bear paw. That'd be weird. But you see a big bear print on the ground. And you're like, what the heck is that? Maybe you've never seen a bear before. You're like, what is this thing? And then maybe you peek around the bushes and you see this giant furry animal and you're like, whoa, that thing can eat me in 5 seconds. So you sneak away. If you see this once, it scares you once, and then maybe 5 years later you don't see it, and then the sixth year you see it again. You're like, oh, what's that? That's a very big paw. Let me go in this cave. What's gonna happen? So if you see that bear track every couple of weeks, you're gonna remember what it looks like piece by piece, and you're gonna know I'm gonna stay away because the first time I saw that bear on the other side of the bush. I know what it's attached to. So if you see it more often, your brain puts it in permanent memory. But if you just see that bear track once and you wait 6 years to see it again, and you go in that cave because you didn't recognize it was a bear paw, good luck. I mean, we're not prehistoric people, but this is just where we came from. This is the caveman times, how our brain developed in the way that it did. This is what happened very often back in the day. Luckily, we have a home. We have roof over our heads. In many cases, we're not going to be dealing with the woods and the bears or wolves or any other animal that can eat us, which is basically all of them. I mean, maybe not all of them will eat us, but if some feel threatened, they'll definitely do something about us. Antlers, they hurt. Crocodiles, they hurt. So it's those kind of things, the survival instincts of the brain that have configured the way we think. And this is why studying one time before the test is not a long term solution. You may pass the test right now, but 4, 5, 6 years down the road, that information is not going to stick. So you have to work with the process. The process is important, not the product. The test is not important. The test comes with the process. You do a good process week by week by week. You have a question, you ask the question. That's why we say if you have a question, there's somebody else in the class that probably has that same question, so you better ask it, right? So always important to ask questions because that's how we learn. I ask a lot of questions when I'm teaching my students, and I also tell them to ask me questions because that's how we exchange. Them not understanding something and asking me about it helps me understand what I have to focus on. And also, them asking the question is a sincere curiosity. It makes them open to the answer. So you're not just speaking into thin air. That's why it's difficult to basically teach in a stream because there's no interaction with people. Maybe one day I'll have uh, calls with anyone that's watching or anyone that has problems, and we'll discuss stuff live on a Discord or some form of communication channel because that interaction is important to learn. Just by watching me, you might get some stuff, but it might also just fly out the window too. It has to be the practice that fortifies that you remember it. So as you're doing this, if you're practicing your own problems, that's probably the best thing to do. Anyway, I've been having this x minus 3 up here for a bit. You figure it out yet? Well, if we had to subtract from a positive 3, if you recall, we had a plus 3 before, dropping back to some problems. But we had to subtract from both sides. Well, that relationship still stands. It's just opposite now. So we technically have a missing group of 3. Hard to represent on a scale because -3 is not a number that we can really show in real life. But we can say it's missing. There's 3 missing. So we give it 3 here, but we also give 3 here. Back to that balance. From there, that's a 0 again. That's always the goal, is to get a 0, to get it out of the way so x stands by itself. You can put a plus there, you can put a minus there. The 0 doesn't have a plus or minus, so you can put whichever one. Normally with a 0, we just put a plus because in the end, it's just going to go away anyway. Go away anyway. And finally, we add the 5 and the 8, and boom. Different answer, which should make sense now. Because we need 2 different numbers to work with the operation. 2 plus 3 is 5, but 8 minus 3 is 5. We're starting from higher, removing 3, we get to 5. 2, we starting lower, adding 3, we get to 5. So the direction is important. But the operation, not so crazy. Okay, let's see. Let me check some stuff real quick. Let's see. So variables essentially work in this factor. They are empty spaces. We're trying to seek out the answer. And if we don't, well, the case is that we can check ourselves. If we're not sure of whether we got the answer right or wrong, maybe we did some simple math, something, I don't know, just woke up, didn't have your coffee or breakfast. Breakfast is important for the brain to work, function properly. We always have the choice of plugging it back in. I did it mentally a moment ago, but we're always able to check ourselves for that 100%. Plugging in 8 minus 3, now it creates our check. You'll see this often too in your problems, the checking point. Being able to check yourself in math. Math is the only subject that you can check yourself and make sure you actually got 100 before you submit your test. That's pretty important. Very important to remember. Let me see here. I want to adjust something. So let me put on some AI music. Kind of take a quick mental break here. Let's do this one. quick break.